For MR of this compound is 46. This is again the higher MR, 24 plus 12 twos are 3s are 12, 36 plus hydrogen 4 plus nitrogen 14, 440 and 36, 40 and 54. This is equal to 54. This is again more 36, 36 plus 16, 3, 4 or 3, 3, 1, 4 or 7 or 8 plus 8. This is also more. So D option is correct because whose MR is 42, lower MR. Question number 32. C4H9Cl reacts with warm dilute aqueous sodium hydroxide solution. Which isomer of C4H9Cl will form the most stable cation intermediate? Tertiary cation is more stable cation. So the 1-chlorobutane. So 1-chlorobutane primary. Carbocation is formed in 2-chlorobutane secondary carbocation. 1-chloro-2-methyl propane. 2-methyl propane. Again because 1 chlorine is going to release, so also formed primary 2-chloro-2-methyl propane. 2-chloro CH3 CH3 CH3. So when partial positive, partial negative, this is intermediate. This is tertiary halogenoalkane and this is tertiary carbocation, which is most stable cation. So D option is correct. 1 mole of an organic compound J requires 6 moles of oxygen for the complete combustion. 1 mole of J reacts with sodium hydroxide of a gas that gives pop with lighted supplant. 1 mole of J reacts with sodium. J reacts with an excess of hot acidified potassium manganate 7 to produce an organic compound which gives an orange-red precipitates with 2,4-DNPH. Which compound is J? But1-ene. So if it gives 2,4-dinitrophenyl hydrazine reagent, so but1-ene is alkene, or alkene does not give the positive test with 2,4-DNPH. So this is incorrect. Butane 2-ol, all are propane 2-ol. So the options will be in B, C and D. Butane 2-ol, if we combustion, first complete combustion has 6 moles. Butane C4H9OH, if react with oxygen in combustion, carbon dioxide plus water. 4 carbon, 9 and 10, 5. So 4 to the 8 and 5, 13. So if we 6 to the 12 and 1. So this is balanced reaction. 6 moles of oxygen is required. 1 mole of gel react with when it reacts with sodium Na to form C4H9O9 and H2. half mole of hydrogen gas is formed. So this must be correct. Propane to all 2-methyl propane to all 2-methyl propane to all butane to all G reacts with excess of hot acidified potassium manganate to produce an excess of acidified potassium manganate to produce an organic which gives an orange red precipitate. Butane to all is further oxidized to form aldehyde, and aldehyde then further oxidized to carboxylic acid. Two methyl propane to all, and G reacts with excess of to all gives ketone, not aldehyde. It is ketone which gives positive test with 2 NDPH. Okay. Propane to all. Two methyl propane to all. OH. So this is tertiary alcohol, this is not oxidized, so it is incorrect. And now propane to all, C3H7OH plus oxygen to form CO2 plus water, 3 carbon 7 4 carbon 4 3 to the 6 and 4 10, and oxygen is not balanced by using 6 moles of oxygen, so that's why this is also incorrect. So butane to all is best option. Structural isomerism and stereoisomers should be considered with when answering this question. 3-methyl hexane 3-ol reacts with hot concentrated sulfuric acid to form several isomeric compounds with the molecular formula of C7H14. So this is the compound CH3 CH2 OH CH2 CH2 and CH3. Hot concentrated acid to form several isomeric compounds with the molecular formula of C7H14. How many isomeric compounds could be produced? 1 2 3 4 5 6 7. This is CH3. One is this compound, CH double bond CH3 and CH2 CH2 CH3. This is one compound, and this has cis trans 2 isomers from this side, and another option is, now if H is removed from, this is elimination reaction, if H is removed from this side, the option is CH3, CH2, CH double bond CH3, CH2, CH2, CH3. So in this case CS cis trans is possible, two cis trans, two isomers are there. Now there is another option. If CH3, CH2, and one of the H is removed from this hydrogen, CH2, CH2, CH3. So the option is CH3, CH2, C double bond CH2, CH, CH2, CH2 and CH3. This is structural isomers. There are no cis trans isomers because two hydrogen is there with this double bonded carbon. So no cis trans but one isomer is there. So total isomers are 5. The option is C. Question number, the table shows the students' predictions for the reactions of 3 compounds. This is aldehyde, alkyne, prediction for the reactions of 3 compounds. This compound is aldehyde. This is HCH3. Yes, alkaline. Statement, reaction occurs, reaction yes. Failing reagent also positive, test also positive. Question, this is ketone, Ci3, positive test with this is correct. Failing reagent incorrect, untolerant reagent also incorrect. Question number 3, this is ketone, CH2, CH3, CH2, CH3. Alkaline, yes. Failing reagent, ketone does not have positive test with failing reagent, does not show positive test with tolerant reagent. This is also correct. 1, 2, 3 all are correct. So option is A. Which mechanism describes the reaction of aldehydes and ketones with HCN and NCN? Electrophilic addition, no. HCN CN is attached, so this is nucleophile. Not electrophilic addition, not electrophilic. This is nucleophilic addition because nucleophile is added with aldehyde and ketones. So C option is correct option. Because in this reaction CH3, C double bond O and Cn negative, partial positive, CH3. So this is like this and this is like this, CH3, CO negative and HCN positive, negative. So this is addition reaction, CH3, COH, CN. Nucleophile is added in this reaction. So nucleophilic addition is correct option. Propyl propanoate can be synthesized in the 3 steps using propene nitrile as the only organic starting material. In step 1, the nitrile is converted into compound X. Nitrile is converted into compound X. Compound X. Step 2, compound X is converted into compound Y. In step 3, compound Y is reacted with more of compound X to give propyl propanoate. Step 2, propyl propanoate. This is if hydrolyzed this compound, the X is CH3 CH2 CO2H. And step 2, again this is ester is formed. So what should be formed at Y? So he asked you that in step 2 compound X is converted into compound Y, and in step 3 Y is reacted with more compound X. This is an ester, and ester is formed by reacting with propanol. So over here dehydration, reduction reaction is added by using reducing agent H to form, in the presence of lithium AlH4, carboxylic acid. Dehydration of this is not reduction of carboxylic acid only takes place in the presence of lithium aluminum tetrahydride. So to form CH3 CH2 CO CH2 OH. So this is Y, and when Y react with CH2 CO2H react with X plus CH3 CH2 CH2OH, ester is formed CH3 CH2 CO2 CH2 CH2 CH3. So this is the product. So we have which reagents are suitable for carrying out step 1 and step 2. So lithium aluminum hydride, and in this hydrolysis HCl, aqueous HCl, to form X is this is Y, and Y react with ester. So A is not correct. B is correct option. HCl in step 1, step 2 lithium aluminum tetrahydride. Question number 38, ester is formed, is hydrolyzed by boiling with aqueous sodium hydroxide. CH3 CH2 CO2 CH3 plus sodium hydroxide plus water to form CH3 CH2 CO2Na plus methanol. So which compound is one of the product? Ethanol is not a product, propanol not, propan 1-ol, sodium methanoate. This is sodium O2CH3, sodium not sodium methanoate. This is sodium propanoate. D option is correct. Compound V polymerizes to form polymer W. A section of polymer W is shown. V is polymerizes to form, so we can see this one unit. This is Cl double bond CH3 and Cl 1, 2 and 3. This is 1 1 2 1 1 2 trichloro propene, 1 1 2 trichloropropene. A molecule of an organic compound P contains 3 carbon atoms and shows a strong absorption of 1720 in its infrared spectrum. P is reacted with an excess of hot acidified potassium dichromate, forming an organic product Q. Q shows a stronger 1720 at 1720. This is carbonyl peak, and P is reacted with excess of hot acidified, means ketone does not further oxidized in the presence of potassium dichromate. Only aldehyde is oxidized to form RCO2H. Q, this is Q, and this is P. This is, sorry, oh my god, this is P and this is Q. P is reacted with an excess of hot. Q shows a strong absorption of 1700 cm. This is a strong absorption of C double bond O, and strong broad absorption, it means strong at 2800. So this is absorption of OH of carboxylic acid. So OH of carboxylic acid is showing broad absorption centered at 2800 cm inverse. It's infrared spectrum, so it should be aldehyde. So this is propanol. This must be correct. Propanone does not further oxidize, so it is incorrect. Propan 1-ol. It is alcohol only OH, and OH only one OH peak is missing, which shows in infrared spectrum is 3200 to 3600. Propan 2-ol, again this is incorrect. Propanol is correct because these two tests, like when P contains 3 carbon atoms and shows a strong absorption 1720, P is react with hot to form Q, which is carboxylic acid, and 1700 is the carbonyl peak, so that's why it is propanol. Hopefully you got it. If you have any query, please ask in the comment box. Okay, happy learning guys. Allah Hafiz.